Let's rock.
The human has been neutralized.
Marvin, in trying to understand the nature of our universe, some people have told me a rather shocking thing, that it may be that it's not just trying to discern all the realities of our universe, but they say what we're living in could possibly be a fake, a simulation. As a computer scientist, what do you make of that?
That's an idea that came, the idea that the world is a simulation maybe comes from some early science fiction where some of the writers imagined people playing games, and at some point inside the game world some creatures appeared who weren't the players. But it's perfectly possible that we are the production of some very powerful, complicated programs running in some big computer somewhere else, and there's really no way to distinguish that from what we call reality. And maybe we are being simulated by some rather large, dumb program. Maybe it simulated all of evolution, and it was set up by someone who wanted to see what would happen on a planet like Earth.
There may be different kinds of simulations. There could be the brain in the vat, where we have real brains, but somehow, like a matrix, it's got a hold of and being fed in all information. That's one kind. Another kind can be we're literally on some supercomputer, maybe a good one or bad one. And a third could be that we are being simulated, but there's a real physical world, but has been created to be a simulated but a real physical world, not a virtual world, but a real world. Do those make sense? I mean, and can we distinguish between those if indeed we're fake?
Right now there are some experiments in physics that have a precision of 16 decimal places.
Wow.
Which is, for example, there's an effect called the Mossbauer effect, where you measure the frequency of radiation from some excited iron atoms, and for some reason I don't understand, these frequencies can be measured better than, as far as I know, anything else. So you could imagine at some point we get even better experimental equipment and start measuring things to 20 decimal places. Well, I could imagine that you might notice in the data that there's something funny about it, that the theory doesn't quite predict what's happening in the last 2 or 3 decimal places, and then some applied mathematician comes along and looks at that and says, oh, this is the same thing that you would get if there were a round-off error in a computer. So there's a sort of interesting possibility that even if we were simulated, we might be able to find some technique that would notice some of the grain of the computer being used is showing through a little bit.
That was a little bit of a lazy computer programmer who only wanted to take it 18 digits instead of 25 digits.
Something like that, right. And that would explain a little, that would resemble a little bit some uncertainty in quantum mechanics, and there might be a similar thing at the other end, that the floating point numbers in this only go up to 256 decimal places, and you notice for very high speed phenomena there's a limit to the speed, somewhat like Einstein proposed, but the speed of light isn't exactly right, and these tiny little fluctuations come because the computer word length is too short. So you could imagine that ultimately you might find some phenomena for which the best explanation was, oh, we're not real. We're just a program on an IBM 68 billion, a Motorola 68 billion or whatever.
Do you take any of that seriously, or it's just an interesting exploratory way of thinking about the world?
Well, my friend Edward Fredkin, who originated a lot of the theory of what's called cellular automata, has been developing some theories of physics in which space is made of little separate points. same sort of thing that Stephen Wolfram works on. And Fredkin has suggested some ways that some laws of physics could appear in there, which would look very much like real physics, except that if you tilted the experiment just right, you could see the sort of crystal planes in this discrete world. And so some very careful experiments might show a grain to the nature of space that we don't see ordinarily. And again, that might show that the real world that we're being simulated in is slightly different from what we thought. So there's a great future there as physics instruments become more and more accurate. They could show up new clues to what reality really is or isn't.
So what would you feel if you found those anomalies so that indicated that this was a simulation? What would your emotion be as a computer scientist?
Oh, I'd be very excited because first it would mean that the universe was more easy to understand than we had thought, and that we might even find ways to change it. And once you understand physics, this is always powerful. If it turns out that physics is actually discrete and separate points, then maybe we could invent new devices that exploit that. And every discovery in science leads to wonderful new applications.
Would also mean, though, that our level of reality is not the ultimate reality, and that you can do all your nice little things in our world, but that you'll have no understanding of what the real reality may be.
Yes, and that might be a great thing, because otherwise we have to say, is this all there is? So wouldn't it be nice to know that we're really part of a bigger universe?